Hello everyone, welcome back to the channel Pharmacology Simplified. In this video, we are going to discuss about the cardiac cycle. So, what is cardiac cycle? Cardiac cycle comprises of all the events that occur during one complete contraction and the relaxation cycle of the heart. So, this comprises one cardiac cycle comprises of actually four events: two systoles and two diastoles. So, atrias will undergo systole as well as the ventricles, and same goes with the diastole. Atria will undergo diastole and the ventricles will undergo diastoles. When we talk about systole is like contraction and diastole is the relaxation. One cardiac cycle roughly takes about 0.8 seconds, and if heart is beating at a rate of 75 beats per minute, then in 60 seconds there would be 0.8 seconds time would be taken for completing one cardiac cycle. If we see cardiac cycle, we can divide it into three phases. First is the atrial systole, second is the ventricular systole, and third is the relaxation period. Right? Atrial systole takes about 0.1 seconds, ventricular systole takes about 0.3 seconds, and ventricular diastole takes about 0.4 seconds, or the relaxation period. So this all in total takes about 0.8 seconds per cardiac cycle. Right? So now we will take each of the steps, each of the phases of the cardiac cycle individually. So first is the atrial systole. Atrial systole is like, systole is the contraction. So when the atrias will undergo contraction, we say it as atrial systole. If you are not familiar with the anatomy of the heart or the how heart works, you may find the link in the right corner. So I would recommend that you go to that video first, then proceeding in this video. Right, so this is the structure of the heart. So we have four chambers: right atrium, right ventricle, left atrium, and left ventricle. So in the right atrium there is sinoatrial node, that is the pacemaker of the heart, and that automatically undergoes depolarization and spreads the impulse all over the atria. So when it depolarizes SA node, it leads to the beginning of the atrial systole. That means atria will undergo contraction. So during contraction, there will be increase in the pressure in the atrial chambers. This will lead to the opening of the atrioventricular valves. So, atrioventricular valves are the valves that send the blood from the atria to the ventricles. So the blood is then pushed into the ventricles, and approximately 25 ml of the blood is pushed into the ventricles during an atrial systole. Why why only 25 ml of blood is being sent into the ventricles? I'll be discussing it in the later part of this video. Ventricles hold about 105 ml of blood already before the atrial systole. So when the atria contract, so 105 and 25 ml blood that is coming through the atrial systole makes up to 130 ml of the blood. This volume of blood is referred to as end diastolic volume. End diastolic volume is the amount of blood or the volume of blood that is present in the ventricles at the end of complete diastole of the ventricles. That means when the ventricles dilate or they spread completely, then the amount of the or the volume of the blood that is present in the ventricles is called as the end diastolic volume, right? And atrial systole is denoted by P wave on the ECG. Next, we move ahead to ventricular systole. That means contraction of the ventricles. It takes about 0.3 seconds. So when the impulse from the SA node spreads over the atrias, it also reaches the AV node, and AV node is the relay station which is responsible for conduction of the impulse all over the ventricles, right? So when the impulse is spread over the ventricles, this leads to ventricular depolarization and the ventricles undergo systole. During the systole, there is increase in the pressure in the ventricles, and this causes the AV valves to shut down. Because the pressure inside the ventricles is increasing, it puts an upward pressure on the AV valves, atrioventricular valves, which shuts them up. Then valves are shut, so AV valves are shut, as well as the aortic and the pulmonary valves, they are also shut. So all the four valves are closed, so there would be no change in the volume in the chamber, but the muscles are still under contraction. So they are generating tension, but their length is not getting shortened. So there is no reduction in the muscle length and there is no reduction in the blood volume. So this type of contraction will be said as isometric, since there is no change in the length of the muscle, and isovolumic, since there is no change in the volume of the blood in the ventricles. This isovolumic isometric contraction lasts for about 0.05 seconds. Since the ventricles are undergoing the contraction, the pressure in the ventricles, it will continue to rise and it will surpass the pressure that is present in the aorta and the pulmonary trunk. Pulmonary trunk originates from the right ventricle and the aorta originates from the left ventricle. Pulmonary trunk sends the blood to the lungs and it holds about 20 mmHg of pressure of the blood, while the aorta holds about 80 mmHg of the blood pressure. So this increase in the pressure in the valves, in the ventricles, lead to the opening of the aortic and the pulmonary valves, and this leads to ventricular ejection. That means the blood will be ejected out of the ventricles, and this ventricular systole is shown as a QRS complex on the ECG. Left ventricle ejects about 70 ml of blood into the aorta. So initial volume of the blood was 130 ml and it is said as end diastolic volume. The amount of blood ejected is 70 ml. So this is the stroke volume. The amount of blood that is sent out of the ventricles into the aorta in one contraction is called as the stroke volume, and so the remaining blood is 60 ml. This is called as the ESV, or the end systolic volume. So opposite to the end diastolic volume, end systolic volume is the amount or the volume of blood that is remaining in the ventricles after one systole, like after the ventricles have contracted. So the amount of blood that is remaining in the ventricles is called as the end systolic volume. So one more important term is cardiac output. Cardiac output is the amount of blood that is being pumped out of the heart per minute time. So cardiac output is stroke volume into the heart rate. So if the stroke volume is 70 ml per beat and heart rate is approximately, or we say theoretically, 75 beats per minute, so this will push 5250, that means 5250 ml of blood, or 5.25 liters of the blood per minute. That means all of the blood in the body is circulated through your pulmonary and the cardiac circulation within a minute. Interesting. And lastly, we will see about the relaxation period. This lasts for about 0.4 seconds. During this, the ventricles repolarize and they undergo ventricular diastole. Diastole is the relaxation. After ventricular systole, the ventricles start to relax, and when the ventricles will relax, you have to imagine this. When the ventricles will relax, the volume of the chamber will start to increase and the pressure will start to decrease, right? Volume and pressure, they are inversely proportional. Higher the volume, lesser will be the pressure. So here the volume is increasing, hence the pressure would decrease. Since the pressure is decreasing, this will close the aortic and the pulmonary valves that was sending the blood out of the aorta and the pulmonary trunk. All of the four valves are closed and the muscles are relaxing, so there is no change in the volume of the blood, right, in the ventricles. So this is also again one more isovolumic, but this time it is relaxation. But since the ventricles are continuously relaxing, the pressure inside the ventricles will continue to get reduced. It will fall continuously. Now, since this will create a sort of vacuum in the ventricles, this will open up the AV valves. The atrioventricular valves will open, and about 45 ml of the blood, it will flow passively into the ventricles. See, I told in the beginning that why only 25 ml of blood is going during the atrial systole from the atria to the ventricles, because the 70 ml of the blood, one stroke volume is 70 ml, so every time 70 ml of blood would be returning back to the atrias. So this, out of the 70 ml blood, when the valves are opening, out of that 45 ml of the blood will be flowing passively into the ventricles, and in the meantime there will be atrial systole again, right? The cycle will be beginning again. So there would be atrial systole, and this atrial systole will pump 25 ml of the blood into the ventricles. So this 25 ml blood and the 45 ml blood that has flown passively, this totals to 70 ml of the blood, and your cardiac cycle will now begin. This relaxation period appears as T wave on the ECG. One more thing you may think of, that why I have not discussed about atrial diastole, right? Atrial diastole happens parallel to the ventricular systole, right? So when our ventricles are contracting, our atrias are relaxing. So it is not appearing on the ECG because the QRS complex overlaps the atrial repolarization phase, right? So this is it with the cardiac cycle. If you have any questions, please post them in the comment section below. If you have been able to understand anything out of this video, please do subscribe to the channel, like this video, share it as much as possible. Happy learning to all of us. Thank you very much.